Hello everyone, my name is Tejagan God and this is my IIT Tech Talk video of subject electric circuits. I am from ECCA section and my roll number is 2295180410 and my topic is about electro electromagnetic uh, electromagnetic fluctuations for anisotropic media and the generalized Kirchhoff's law. Interaction electromagnetic fluctuations in anisotropic media occur when the medium has different electrical magnetic properties in different directions. They are important in many areas of physics, including optics, condensed matter physics, and material science. The generalized Kirchhoff's law is a useful tool for studying electromagnetic fluctuations in anisotropic media. Anisotropic media can exhibit an introduction to this is the introduction applied electromagnetics and optics. And the anisotropic media have different properties in different directions. They are characterized by a tensor called the dielectric tensor, which relates the electric field to the polarization density. And anisotropic media can exhibit birefringence, dichroism, and the other optical effects. And in this, the polarimetric emission parameters for anisotropic media are derived using the generalized Kirchhoff's laws for media with a uniform temperature and the fluctuation dissipation theory for media with a temperature profile. Both finite size objects and off-phase media are considered when the object has a uniform temperature across its body. The Kirchhoff's law, based on the condition of energy conservation in thermal equilibrium, is generalized to obtain the emission parameters of an anisotropic medium, which can be interpreted as absorptivity or the absorption cross section of the complementary object with a permittivity that is the transpose of the original object when the medium has a non-uniform temperature distribution. The fluctuation dissipation theory is applied for deriving the convergences between vector components of the thermal currents and consequently the covariances of the polarizations of currents to verify the formulas derived from the fluctuation dissipation theory. We let the temperature of the object be a constant and show that the result reduced to those obtained from the generalized Kirchhoff's laws. Electromagnetic fluctuations are spontaneous random variations in the electric and magnetic fields. They arise due to quantum mechanical effects and are present even in vacuum. Electromagnetic fluctuations can be studied using the fluctuation dissipation theorem. This is the electromagnetic shown in the figure. Magnetic field B, electric field propagation direction, wavelength lambda, And this is the diagram of electromagnetic wave. Next is generalized Kirchhoff's laws. The generalized Kirchhoff's law relates the fluctuating currents and fields in an anisotropic medium. It can be used to derive expressions for the spectral density of the electric and magnetic fields in the medium. The generalized Kirchhoff's law is a powerful tool for studying the effects of anisotropy on electromagnetic fluctuations. Notes, there are three types: nodes, branches, and loops. Node is a point where two or more elements are joined. Loop, a closed path that never goes twice over a node. Example, the blue line is a node. The red path is not a loop. Example, the blue line. The red path is not a loop. Branch, component connected between two nodes is called branch. Example, component R4. A node connects several components, but it does not hold any charge. Total current flowing into the node must be equal to the total current out of the node. A conservation of charge principle. Next, spectral density. The spectral density of the electric and magnetic fields describes the distribution of fluctuations as a function of frequency. It is related to the dielectric tensor of the medium and can be measured experimentally. The spectral density can be used to study the effects of anisotropy on electromagnetic fluctuations. Spectral density, the graph of spectral density is intensity counts wavelength nanometers in nanometers. Applications: electromagnetic fluctuations in anisotropic media are important in many areas of physics and technology. The electromagnetic fluctuation applications, they play a role in the behavior of liquid crystals, semiconductors, and other materials. They are also They are also relevant to the design of optical devices such as polarizers and wave plates. For thinner films, electromagnetic fluctuations make these films less stable and contribute to their stability for thicker films. This effect to their stability for thicker films. This effect may be useful to ensure the film stability in the next generation of organic based electronic micro devices with further decreased dimensions. Why electromagnetic waves have a vast, vast range of practical everyday applications that include such diverse uses as communication by cell phone and radio, by broadcasting, Wi-Fi, cooking, vision, medical imaging, and treating cancer. The examples of electromagnetic waves in our daily lives are radio and television, microwave ovens, medical examinations, sterilization, communication devices, radar, military equipment, cancer therapy, and the experimental techniques of electromagnetic fluctuations for anisotropic media. There are several experimental techniques for studying electromagnetic fluctuations in anisotropic media. These include optic spectroscopy, microwave spectroscopy, and scattering experiments. These techniques can provide information about the dielectric tensor and the spectral density of the medium. Modeling techniques. The modeling techniques such as numerical simulations and analytical calculations can also be used to study electromagnetic fluctuations in anisotropic media. These techniques can provide insights into the behavior of complex systems such as liquid crystals and biological membranes. They can also be used to design new materials and devices with specific electromagnetic properties. And the future direction, the study of electromagnetic fluctuations in anisotropic media is a rapidly evolving field. New experimental techniques and modeling approaches are constantly being developed. Future research will focus on understanding the behavior of complex systems and designing new materials with tailored electromagnetic properties. The conclusion, propagation of electromagnetic waves in weakly anisotropic media, theory and applications. There are two basic approaches for description of electromagnetic waves in a weakly anisotropic media. Quasi-isotropic approximation of the geometrical optics method and Stokes vector formation. Electromagnetic fluctuations in anisotropic media are an important area of research in physics and materials science. The generalized Kirchhoff's law is a powerful is a powerful tool for studying these fluctuations. Electromagnetic fluctuations in anisotropic media conclusion are an advances in experimental electromagnetic fluctuations in anisotropic media conclusion. Advances in experimental and modeling techniques will continue to drive progress in this field. The role of electromagnetic wave abstract these organic films find expanding applications and in electronic and optoelectronic electronic devices, biotechnology, food packing, and for many other purposes, among other factors. The stability of films with a thickness below a micrometer is determined by the zero point and thermal fluctuations of the electromagnetic field. These fluctuations result in the van der Waals and Casimir free energy and forces between a film and a substrate. And thank you.